Okay. In reference to a chemical reaction or chemical equation. You want more expensive seats?
Yeah,
That's
we're
fine.
upgrading to court-side views.
Okay. I mean, that's fine. All right. So, with that, what is everything you can tell me about a chemical reaction?
Has to be even on each side.
Okay. That means it's balanced. That's right. What else? Oh, also, before I forget, I do have a paper I'll sign in a few moments. And we've also got vocabulary that is due on the 10th. So when is that?
Next Thursday.
Next Thursday.
That's on March
Okay.
10th.
That is March 10th. That's correct. That's why we have it due on the 10th. Okay. Someone give me an example.
Zinc.
Okay.
No, we do that
Iron.
Iron.
Gold.
We need to do mercury.
Well, I heard zinc first.
Do a tungsten. W.
Gold.
Okay. A polyatomic ion now.
Wait, how do you figure out?
A polyatomic ion.
Krypton.
See, what about if we said clear down? Ion. Polyatomic ion, yes. Yes. Polyatomic ion. Carbonate, phosphate, hydroxide, nitrate.
Oh, carbonate.
Sulfate.
Okay.
Zinc's got a +2.
Potassium I'm running out of space, okay? I need to keep that material up there for the seniors. Okay, this is one upon some of the concepts or content that you have, okay, that we did last chapter. If we had problems last chapter, it is only going to compound itself into this chapter, okay? So you still have opportunities to say before school, after school, say I need help. Find a junior, a senior to help this out, help you out with this content, or come and talk to myself. You have those opportunities, but you need to make those choices. You have that as well. Okay, so potassium, what is the symbol?
K. CN. CO3.
Okay, so this is by itself. Go by your negative ion. What does carbonate have for a negative charge?
-2.
Okay, what does zinc have for a charge?
+2.
Why didn't we put zinc 2 carbonate? Because it's a D block element.
You did?
Said, why did we not?
Oh, because the charge is already 0.
No. That doesn't say, why did we not put this in there? Because zinc is a D block element.
It only has one charge.
It only has one charge of +2. All right. So, what does that mean if it's on the left-hand side of the arrow?
It's the product.
On the left side,
It's the reaction.
it's the reactant. Then the products are on this side. What is zinc? Well, it's this is potassium carbonate.
CO. CO.
Okay, the charges do not add up, or the charges, do they add up to 0?
No.
They don't change. So what do we got to do?
Put a 2 for the potassium.
Okay. Therefore, these are all 1s right now.
I have a question.
Yes.
On the top, how'd you get potassium with carbonate? Do you just switch them?
Yes. That's one of the things we're going to be working on later this week. You're going to have to be able to recognize these reactions as well. Okay? So, how do you want to approach balancing this?
To the left.
Okay, give me some elements.
Potassium 1 on the left. Carbonate.
Is that it?
Yep.
Okay. So, potassium's left.
1.
Potassium's right.
1, 2.
Zinc's left.
1.
Carbonates.
1.
Okay? So it looks to me like there's only one place to start. You've got 2 over there and only 1 over here.
So you're gonna add a.
That's it. Now we're done.
That's all you need to do.
That's it. Some of these are very simple. Some of them are a little more complex. Okay? That's just the way it is. Okay? So some of you are choosing to write this down, which is fine. If you're choosing not to, that is your choice. All right. At your young men's and women's age, does any of you ever rode a motorcycle or rode as a passenger on a motorcycle? Down the interstate perhaps, or the highway? On a highway, either one or the other. Okay? How close have you gotten to a vehicle in front of you?
Pretty close.
Pretty close.
Okay?
Say about 20.
2 things. 1, ride with your mouth shut. Don't open your mouth. You might get a bug in your mouth. 2, you don't have to have your mouth open, but do you ever notice some precipitation that hits you in the face?
No.
Are you just saying that? Okay. Well,
Why wear a helmet and goggles?
okay.
Helmet when you come on a motorcycle in the summer.
Yeah. Sometimes. All right. So with that, octane. Okay. This is going to be one of the aspects that we get to organic chemistry. Octane is C8H20. Okay? The only reason you would know that is because I'm telling you that. Okay? So when hydrocarbons burn, whether it's gasoline or this octane, or whether it's diesel fuel, which is 1 carbon heavier than 1 or 2 carbons heavier than 8, okay? What do you suppose this has to combine with in order to burn? We just write it like that. You said oxygen, that's right. What about oxygen? Why? But you say you need a couple of them, that's right, but why?
So it's balanced?
No. What does it mean when gases are by themselves?
Then they're stable.
It's the ladies in the upper right-hand corner here who had said that. What's significant about this? Starts with the letter D.
Diatomic.
What does it mean to be diatomic? You have to have 2 of them. If you don't put that there, doesn't matter what you do, anything beyond that is going to be 100% wrong. So how many times have you heard that term diatomic? 5?
7.
I don't know, possibly 7. Okay, so you are behind a vehicle, on a bike, motorbike, motorcycle, whatever. Okay, when this burns, you get this as a byproduct, always in a combustion reaction. Also, this is why we say you get splashed in the face with what you think is precipitation, because as engines combust, they give off water as a byproduct. Okay? So, do any of you ever have to start your vehicle in the morning before you come to school? You let it warm up for 5 minutes. Okay? Well, but if you do that, what do you notice on the backside of your exhaust and or tailpipe? There's water dripping out of there because of this byproduct. Okay. Now, I'm just going to put this up here.
Is that O supposed to be bigger? On the left, H2O.
That's 20.
But then why do you have H2O on the right?
Because I'm telling you, you need water over there. Okay? Okay, this is also a combustion reaction. What do you suppose you get for byproducts? What do you suppose you get for byproducts? Carbon dioxide or CO2 and water. Okay, now, as you look at these, if you had to balance this, who would rather balance the top one? Who would rather balance the bottom one? Okay? So the rest of you, either you don't know or you don't want to raise your hand. These two guys are a little bit ahead of everybody else. I would rather do the bottom one.
Yeah, let's do the bottom one.
Okay? Now, the best way that I can explain this, okay? You can either look at this as, I just thought of this, pheasant hunting. What about it?
Pretty neat.
Okay? Can you shoot at every bird?
No. That's a problem.
You shoot at every bird.
Flies and dies.
Opposite drops.
Okay? Why can you not shoot at every bird? Well, one might be a hen. Okay?
Or there's something in the way.
And the other aspect that we're trying to make sense of is as follows, and that is, for those of you who participate in basketball, we make this correlation. If you are the point guard, you're bringing the ball down the court. Sometimes you need to recognize, what is the defense doing? They're all standing around the lane. They're in a zone defense. That's not what we're getting at. But if the defenders are all trailing your teammates, they're in man defense. Okay? You have to notice, are they in this type of defense or in this type of defense? Okay? So the key to this is you need to be able to recognize this in the hydrocarbons. Hydrogen and carbon. These are hydrocarbons. No surprise, right? Hydrogen and carbon. What do you notice is the difference between, besides the numbers, what's the difference between those two hydrocarbons? The letters are the same. They're both carbon and hydrogen. Besides the color. What about the numbers?
The one's 12 apart.
True. What about the carbons specifically?
Went up by 3.
What's the difference between the numbers?
One's 3, one's up by 4.
What are you on? We're at 8 and 11.
when you categorize 8 and 11, besides being a difference of 3, what else can you tell is the difference?
One's even.
One is odd,
Another one's even.
one is even. If you recognize this, okay, if that number is even, you will make things a lot easier on yourself if you double that right away. If it is odd, like you two had said, you'd rather balance this, you can just jump right into this and balance it. Okay, so which one would you like to look at first? The top one. Okay, so let's go. Whoever's doing that, please stop. Okay, you've got carbon, oxygen, and hydrogen. Okay, so
All ones.
carbon's left, carbon's right, oxygen's left, oxygen's right, oxygen's right, hydrogen's left.
I can't see it.
Well, if you wrote it down, I bet you could see it.
20.
And 2. Okay. Now, this is what happens if you try to do this in a similar manner. If you do this, okay, we got 8 and 8. If you try that, okay, you're going to change this to 8. That is now balanced. What does that do to your oxygens over here? 8 times 2
Is 16.
plus 1 more.
Is 17.
Okay. Now, let's go ahead and look at your hydrogens. You've got 20.
Play that again, please.
Okay? If you got 20 over here and you've got 1 over there, what can you do? Okay?
Now you got 27
No, you don't.
16 and 10. Something's not right here.
You have 26.
This is why. 18, not 20. Okay?
So we have to redo it.
So now I led you astray here. That wasn't intentional. Okay? You had 18 here. How do you get 18 over here? Okay? Now when you do that, okay? 8 times 2,
16.
9 times 1.
9.
Okay? So 9 and 16 gives you what?
Big number.
25. Okay? There's no way to get an even number to an odd number. Okay? We can't do this. Okay? Okay? Nope, that's not right. You can't do that. 12 and a half times 2. Okay? So, when you recognize this and say, oh, since this is even, if you put a 2 in front of there right away, okay, that changes this to 16. So how do we get 16 carbons? Okay? Now, what does that do to your oxygens? You got 16 times 2.
Gives you more.
16 times 2.
32.
Okay? And 1 more.
33.
33. Okay? Then, okay, go ahead and do your hydrogens. 2 times 18 gives you what?
36.
There's only 2 over here. How do we get this up to a 36? Okay? So now your hydrogens are now balanced. Okay? Now, 16 times 2. 18 times 1.
18.
Now you have an even number to work with. 25. 25. Okay? So, what are your 4 coefficients? 2, 25.
16 and
Okay? Now, if we were to do this for this reaction, okay? Since this is an odd number, I'm just going to use these same numbers. Okay? So, if you have 11 carbons over here, how do you get 11 over there?
Divide by 11.
Okay?
Or do you double it?
Wow.
Okay? Carbons are now balanced. You've got 24 hydrogens.
Times it by 12.
Okay?
Wow.
Hydrogens are balanced, carbons are balanced. Oxygens, 11 times 2,
22.
23 ox.
12 times 1.
12.
Now you have an even number again.
Then you put
34 divided by 2.
Okay? So what are your coefficients here?
11, 11. What?
You said 11.
Yeah, 11.
17.
Okay.
No, it's oxygen. No, it's oxygen.
What's this one?
11.
And the last one.
I can't see that.
12.
Isn't it 1 up front?
I think so.
Who said 11?
One of your
I didn't
classmates.
say 11.
Yeah, you did.
I had to take you behind the shed.
Okay, that is the difference. If you can recognize that right away, you will make things a lot easier for yourself. Okay? Okay. For those of you, if and or when you work with other people, that is fine. But what trap do we continually fall into? Yeah, because if you are just writing down what a classmate of yours has, and you don't know how to do it, then you're doing this on your own, on your evaluation. What problem is there with that? You might not know how to do it. Okay? So, I would like to know, why do some of us maybe, I'm not saying we are, but do you think there's a pretty good chance that that happens?
Yeah.
Okay, so if that's the case, why do we do that?
Because they don't want to take the time to
Maybe so. All right. Okay. We got this paper I'm going to hand out here shortly. And when is that due?
Friday. Thursday. Wednesday.
Wednesday.
Why is there so many letters?
Okay.
Why is the vocab due before the vocab's actually due after?
These papers are due on the 9th. Okay. This is due on the 10th. All right. So we will catch up to you next time.